السلام عليكم ورحمة الله وبركاته. Today we will make a final revision on geometry. We must remember that we study the circle and we study the relation between circles and points and circle and straight line and so on. First of all, if straight line passing through the center of the circle and the midpoint of any chord of it is perpendicular to this chord. This means that if AB is chord of the circle M and C is midpoint of AB, then MC perpendicular on AB. If a straight line passing through the center of the circle and perpendicular to any chord of it, bisect this chord. This means that if AB is a chord of the circle M and MC perpendicular on AB, where C belongs to AB, then C is midpoint of AB. The perpendicular bisector to any chord of a circle passes through the center of the circle. If AB is a chord of the circle M, C is midpoint of AB, and a straight line L perpendicular on AB from the point C, then M belongs to the straight line L. Positions of a point with respect to a given circle. A is outside the circle or on the circle or inside the circle. If A is outside the circle M, so MA greater than R, such that R is the radius of the circle. If MA equal R, then this means that A is on the circle. If A is inside the circle, so MA less than R. What about position of a straight line L with respect to a circle M, which add distance MA from its center? L lies outside the circle. This means that MA greater than R. If L touches circle M, this means that MA equal R. If LA is a secant to the circle M, this means that MA less than R. The tangent to a circle is perpendicular to the radius drawn from the point of tangency. If L is a tangent to the circle M at the point A, so that MA perpendicular on L. We must remember that also the straight line which is perpendicular to the diameter of the circle at one of its endpoints is a tangent to the circle. This means that if AB is a diameter of the circle M, L is perpendicular on AB at the point A, then L is a tangent to the circle M at the point A. The two tangents which are drawn from the two endpoints of a diameter of a circle are parallel. If AB is diameter and LK are tangent to the circle M, this means that L parallel to K. What about positions of circle M with respect to the circle N? To determine the position of circle M with radius length R1 with respect to the circle with radius length R2, find R1 minus R2 or R1 plus R2, then use the following diagram to determine the position where R1 greater than R2. If Mn equals 0, this means that two circles are concentric. If Mn equal R1 minus R2, they are touching internally. If Mn equal R1 plus R2, touching externally. If Mn less than R1 minus R2, one inside the other. If Mn greater than R1 minus R2 and less than R1 plus R2, they are intersecting. If Mn greater than R1 plus R2, they are distant. The line of the center of two touching circle passes through the point of tangency and is perpendicular to the common tangent at this point. If the two circles M and N are touching at A, L is common tangent to them at A, then Mn perpendicular on AL. The line of center of two intersecting circle is perpendicular to the common chord and bisect it. If M and N are intersecting circle at A and P, then MN perpendicular on AB, AC equal BC. This means that MN is the axis of symmetry of AB. Equality of arcs in measure and length. In the same circle or in congruent circles, if the measure of arcs are equal, then the lengths of the arcs are equal and vice versa. If measure of arc AB equal measure of arc CD, then the length of arc AB equal the length of arc CD and vice versa. The two parallel chords are drawn in the circle, then the measure of the two arcs between them are equal. If AB and CD are parallel, then measure arc AC equal measure arc BD. If a chord is parallel to a tangent of a circle, then the measure of the two arcs between them are equal. If CD parallel to AB, then measure arc EA equal measure of arc EB. Important to notice, the measure of the arc over 360 equals the length of the arc over 2 by r. You can find the measure of the arc by knowing the length of the arc and vice versa. Equality of two chords in length. In the same circle or in congruent circle, if the measure of the arcs are equal, then their chords are equal in length and vice versa. This means if measure arc AB equal measure of arc CD, then AB equal CD and vice versa. In the same circle or in congruent circles also, if chords of a circle are equal in length, then they are equidistant from the center and vice versa. If AB equals CD, MX perpendicular on AB, MY perpendicular on CD, then this means that MX equal MY and vice versa. Central angle, an ascribed angle, and angle of tangency and relation between them. We study this lesson, and this is important also lesson. The measure of central angle equal the measure of subtended arc. In this figure, measure of angle M equal measure of arc AB. Another case, measure equal twice the measure of the inscribed angle subtended by the same arc. Measure of angle M, central angle, equal to measure of angle A, inscribed angle. Equals twice the measure of the angle of tangency subtended by the same arc. Measure of angle M equal to measure of angle ABC. The measure of the inscribed angle. May be equal half the measure of the subtended arc, measure angle equal half measure arc BC, equal the measure of the inscribed angle subtended by the same arc, measure angle A equal measure angle D, equal half the measure of the central angle subtended by the same arc, measure angle A equal half measure angle M, or measure angle M equal double of angle A, equal to the measure of the angle of tangency subtended by the same arc, measure angle C equal measure angle ABD. In the same circle or in any number of circles, the measure of the inscribed angle subtended by arcs of equal measure are equal and vice versa. If measure arc AC equal measure angle arc FD, so that measure angle B equal measure angle E and vice versa. The inscribed angle in the semicircle is a right angle if AB is diameter, then measure angle C equal 90 degree. The angle of tangency is supplementary to the drawn inscribed angle on the chord of the angle of tangency and in one side of it. If measure angle AEB is inscribed drawn on AB, angle ABD is angle of tangency, then measure angle ABD plus measure angle AEB equal 180 degree. To prove that BD is a tangent to the circumcircle of triangle ABC, prove that measure angle ABD equal measure angle ACB. Relation between tangents of the circle. The two tangent segments drawn to a circle from a point outside it are equal in length. AB and AC are tangent segments to circle M, then AB equal AC. AM bisect angle BAC and angle BMC. AM perpendicular on BC and bisect it. And we also studied cyclic quadrilateral. It's important lesson, very important lesson. Let's remember the cases of this cyclic quadrilateral. If there are two equal angles, when is the quadrilateral cyclic? First case, if there are two equal angles and measure and drawn on one of its sides, a base and on one side of the side. If measure angle BAC equal measure angle BDC. If there is an exterior angle at any of its vertices equal in measure to the measure of the interior angle at the opposite vertex. Measure angle ABE equal measure angle D. If there are two opposite supplementary angles, measure angle A plus measure angle C equal 180. If there is a point in the plane of the figure such that it's equidistant from its vertices. If measure angle FMA equal MB equal MC equal MD. Properties of cyclic quadrilateral. Measure angle 1 if we have ABCD is cyclic quadrilateral. There is some angles 1, 2, 3, 4, 5, 6, 7, 8. We notice that measure angle 1 equal measure angle 2. Measure angle 3 equal measure of angle 4. Measure angle 5 equal measure of angle 6. Measure of angle 7 equal measure of angle 8. In this case, MA plus measure of angle A plus measure of angle C equal 180. Measure of angle B plus measure of angle D equal 180. In this case, measure of angle ABE equal measure of angle D. Measure of angle DCF equal measure of angle A. Well-known problems. Well-known problem 1, if A, B, C, D are two chords in a circle intersecting at the point E, then measure angle AEC equal half measure of arc AC plus measure of arc BD. Well-known problem 2, if CB and ED are two chords in a circle where CB belongs to ED equal A, CB intersect ED equal A, then measure of angle A equal half measure of arc CE minus measure of arc BD. Circum circle and inscribe the circle of the triangle. The circum circle of the triangle is the circle that passes through vertices of the triangle and is the center at the point of intersection of the perpendicular bisector of its side. Then describe the circle of the triangle as the circle is that touches all sides of the triangle internally and its center is the intersection point of the bisector of its interior angles. Notice that center of the circum circle of the right angled triangle is the midpoint of its hypotenuse. Center of the circum circle of equilateral triangle is the same center of the inscribed circle to it, which is the point of intersection of the axes of its sides and the point of intersection of its medians and the point of intersection of the bisector of its interior angle and also point of intersection of its altitudes. It's possible to draw a circum circle to a rectangle, a square, and an isosceles trapezium, while it's impossible to draw a circum circle to a parallelogram, a rhombus, and not isosceles trapezium. There is some important theorems and their proof. We must remember the theorems and their proof. Theorem 1, if a chord of a circle are equal in length, then they are equidistant from the center. We have given that this circle AB equals CD, MX perpendicular on AB, MY perpendicular on CD. We need to prove that MX equal MY we have a construction. We must draw MA and MC. Since MX perpendicular on AB, then this means that X is midpoint of AB and AX equal half AB. MY also perpendicular on CD, so Y is midpoint of CD, and then since AB equal CD and CY equal half CD, this means that then AX equal CY. And triangle AXM and CYM both have AX equal CY, A equal MC equal R, measure angle AXM equal measure angle CYM equal 90 degree, so that triangle AXM is congruent to triangle CYM, then we get MX equal MY. Theorem 2. The measure of the inscribed angle is half the measure of the central angle subtended by the same arc. Given in the circle M, angle ACB is an inscribed angle, angle AMB is a central angle, measure angle ACB equal half measure angle AMP, angle since AMB is an exterior angle of triangle AMC, then measure angle AMB equal measure angle A plus measure angle C, MA equal MC to radial length, then MA equal measure angle A equal measure angle C. From 1 and 2, we get that measure angle AMB equal to measure angle ACB, then measure angle ACB equal half measure of angle AMB. طبعا يا جماعه ده كان ملخص بسيط لمنهج الجيومتري في الترم الثاني. اتمنى ان شاء الله ان لكم التوفيق جميعا وربنا يوفقكم يا رب باذن الله والسلام عليكم.